This is just a short presentation on the use of Wolfram-Alpha to solve quadratic equations or more complicated equations. This is the program that I've mentioned in lecture. This is what I use. You can use some other app if you're more comfortable with that, of course, but I'll just show you what I use to solve some of these equations we come across. If you recall from lecture 2, one of the example problems, we set up an equilibrium situation where, of course, we wanted to get the value of x so that we could solve for the equilibrium concentrations. And when we did that, we came up with an expression that looked like this. And if we went to the next slide, the expression would then be in this form. And I mentioned on the slide that you can use Wolfram-Alpha to solve this. So I'm going to bring up Wolfram-Alpha in a small window on the right here. And basically, if you type your equation in this box and click this little icon or hit return, you can solve the equation. So let's try it. On this equation right here on the top of the slide, we're going to put in this box. So I have x caret 2, meaning x squared, divided by parentheses 1.20 minus x times 0.800 minus x equals 3.75. Well, the nice thing about Wolfram-Alpha, I'm going to click this little icon, is that it will tell you what it thinks you're asking it in this input box. And you'll notice right here that Wolfram-Alpha has misinterpreted what I meant to do. This 0.8 minus x should be in the denominator underneath this line. The other thing that Wolfram-Alpha did was it said, I don't care in the least about the zeros you put in there and significant figures. That's fine. So what I'm going to do is go back up in this box and put an extra set of parentheses around everything we want in the denominator. And just to make it look nicer, I'm going to put brackets instead of parentheses, although I don't think Wolfram-Alpha cares in the least. I click this icon here. I check to see if it's interpreting what I want to do correctly. It apparently is. So I scroll down here and get two solutions for x, 2.10553, which I rounded to 2.106, and 0.621738 that I rounded to 0.6217. Now, if I had solved the equation by hand and put it in this form, so I had an a and a b and a c to put in the quadratic formula, I could still use Wolfram-Alpha, this time in a different way. I could use something called a quadratic solver, which I will find by typing in the obscure term quadratic solver. I get this box here that asks for some input. The quadratic coefficient is the coefficient in front of the x squared term. It's 2.75, so I will put that right there. The linear coefficient is the number in front of the x term. It's minus 7.50. And the constant coefficient is the c term, or 3.6. If I put those numbers in and click compute and scroll down, you'll see we get our two values of x, 2.106, 0.6217, for some reason already rounded off nicely. Well, what happens if we have a more complicated equation than a quadratic? Well, nothing changes. You just type in the equation. So let's go to the slide in lecture 2 where we talked about the Haber process, and in trying to calculate equilibrium concentrations, we found we were up against not a quadratic. We were up against an equation that had an x to the fourth and an x to the third in it. And I had mentioned that, look, we just need to use something to solve this equation. And I put a link in for Wolfram-Alpha again. So what I'm going to do is type this equation into the equation box, and by this equation I mean this one right here. So I'll put in 2x quantity squared divided by, remembering my extra set of parentheses, I'll use a bracket, 1.50 minus x times 4.50 minus 3x quantity cubed, close that bracket, equals 1.44 e to the minus 5. Notice how I entered the times 10 to the minus 5. I'm not sure if Wolfram-Alpha would handle it if you type times 10 to the minus 5. I didn't go there. This is what I'm used to for syntax for these types of programs. Also, if you thought about putting a space between the equal sign and this expression to the left and the equal sign and this 1.44 times 10 to the minus 5, I found that Wolfram-Alpha doesn't care in the least about that. If I put a time sign in between these two parentheses, and by times I mean an asterisk, it's okay with that. Let's click the icon and see if it's interpreting what I want. Looks like it is. So let's scroll down here, and we have 4 values of x, which look strikingly similar to the 4 values I listed in the slide, and this allowed us to pick out a reasonable value to finish the problem. So again, I have found Wolfram-Alpha to be very handy. You may find a phone app or some other program that would help you or you like more than Wolfram-Alpha, which is fine. It's just that this is something that you just can't do by hand, and having some program to solve equations like this will allow us to do some more interesting equilibrium problems.